The Euclidean geometry is an axiomatic system. What that means is this word axiom. The system is based on a set of assumed truths. Okay, so we've already talked a little bit about some of them. Okay, so the first principles. Okay, so these are the basic foundational principles that you have to just assume are true. There's no way to prove them. And in geometry, what have we already talked about that has just been assumed to be true, or things that you can't actually prove or demonstrate? We gave them a name of undefined terms, right? So we already have a set of undefined terms, point, line, and plane, the building blocks of geometry. Those are part of what is just assumed to be true. I mean, we have a definition for them. There's no way to verify or confirm that they are, in fact, real. And so any axiomatic system is based on a set of first principles, or, again, just the smallest thing that you can possibly accept without demonstrating or proving that they are true. You just have to accept it. Okay, so these are accepted as true. And there's a couple other things that kind of move beyond this as far as what are accepted as true. And they kind of fit under these first principles as well. One is what's called postulates. And another is called, in this case, axioms. Right. Axioms are also going to be referred to as common notions. I'll distinguish these as we move along. But let's start with postulates. Or actually, let's start with the difference between these. Okay, comparing postulates versus axioms. Okay, they're both accepted as true. They're undefined. They're a set of assumed truths. The difference is when you hear the word postulates, postulates are specific to a single field. So if you have a postulate in geometry, that assumed truth is only held in geometry. It's not something that carries over into another type of math field or a science field. And so postulates are specific to a single field, and because we're dealing with geometry here, anything that we write as a postulate or a postulated relationship means it's accepted as true without actually proving it, is specific only to geometry and for this class. In contrast to that, an axiom is very generalized. It applies to multiple fields. Okay, so an axiom is going to be true in geometry, algebra, physics, chemistry, any other math or science field. It's based mostly on logic. And so it applies to multiple fields. Postulates, on the other hand, are based on, at least for what we're going to be dealing with, are based on constructions. So they are specific to geometry. Okay, so that's kind of how they are different. They're different in these ways. They're the same, or they're similar in that they're both accepted as true. They're both first principles of this axiomatic system. They're both a set of assumed truths. Okay, now, axioms versus common notions. How are those different from each other? Okay. As far as these two terms go, they're almost like the undefined terms and building blocks. Is there any difference between what these terms represent? Undefined terms and building blocks? No, they both refer to the exact same thing. It's just different ways to name them. And axioms and common notions are the same. They both refer to these logic-based generalizations of accepted truths. Common notions will generally be referred to in the historical sense, whereas axioms will be more modern. Okay, so as far as they're applied in the modern sense. And so most of them will kind of map onto each other. They will have a set of relationships in in terms of a common notion and in terms of a more modern abbreviated way to refer to those. Usually I'll refer to the axioms, but I just want to introduce you to it or expose you to those in the different forms anyway.